section 4.3, and this, it first talks about isosceles triangles, and then at the bottom of the page, that theorem 4.5.207 says, in an isosceles triangle, the angles opposite the congruent sides are congruent. So, oh, and by the way, another thing about proving something, you can't jump ahead of where we're at and give a reason. Like you can't use theorems in chapter 5 to prove things in chapter 4. I mean, it's stuff that you have already had covered. You can't use theorems ahead. Because it's a building process. So theorems in chapters 1, 2, 3, 4, if you're whatever section you're in, you can use everything previous, but you cannot use things ahead. Because what ahead is doing is it's using things in chapter 4 to prove things in chapter 5. So you can't use things in chapter 5 to prove things in chapter 4.
So you kind of look backward, that's what it is.
Yeah. So then the corollary 4.6 there, every equilateral triangle is equiangular. Now, these equilateral and equiangular postulates, 4.6 and 4 on page 208, 209, those are applying to angles and sides in a triangle. You cannot, there's no such thing as 3 angles of one triangle equal 3 angles of another triangle, and therefore the triangles are congruent. It's just saying when you have an equilateral triangle, if you have angles equal in a triangle, then the sides all have to be congruent. If the sides are congruent, then the angles are congruent. And in isosceles, 2 sides are congruent, then the angles, at the base are congruent. If the base angles are congruent, then the sides, it's an isosceles triangle. So don't try to extend it into congruency of a pair of triangles. In 4.9 it says, if an isosceles triangle, the ray that bisects the vertex angle bisects the base and is perpendicular to it. Then that median at the bottom of page 210 is a line that connects the vertex to the midpoint of the base, and it makes the 2 sides equal. Now that's not, that median, don't conflate that with the angles at the top, that it bisects the angles at the top. That's only if, let's see, what am I trying to tell you? If you have an isosceles triangle, where those 2 sides, where this isosceles triangle, this side and this side are congruent, then a median, which divides, is that dotted line that comes down from the vertex down, then it bisects this angle in an isosceles triangle. But if you have a triangle, and you have a median, now this side and this side are not congruent, and these angles are not equal. Don't bisect the angle. It's only when it's isosceles. If in isosceles you could talk about a median, that'd be from the vertex to the opposite, is going to bisect the angles up here and make these sides congruent. So just don't try to make a median line into something that says the angles are equal at the vertex, because that's just not so. And 211 talks about perpendicular bisector theorem. Now that's an if and only if statement. It says P is perpendicular bisector of AB if and only if AP and equals PB, so it's isosceles. So those are the theorems that you have extra along with this exterior angle theorem on page 212. Now in the problem set, starting at page 219, the problems 1 through 8 are not proof problems per se. They're just kind of a justification problem. But problems 9 through 20, those are 2-column proof problems. You make a statement, you say why it's true. Make a statement, say why. Because it says proofs. And then it'll say, notice in the statements it'll say prove this, prove this, prove this. Where the other ones are going to be saying show or verify or justify. That's not a proof problem. That's the difference between these.
So when you say show, do you have to make a statement?
Well, you can make a statement. You can say that this is so because it's an isosceles triangle, but it isn't as rigorous as a proof problem. That's generally what you do. So number 2 says in the triangle PQR, the angle P is congruent to angle R. QT bisects angle PQR and angle R is 61 degrees. Find angle PQT, justify your answer. So you see it's not a proof, it's just saying, justify this thing. So.
And the word bisects clearly states that it's cutting it in half.
Cutting it in half.
Okay, thank you.
Yeah. So the angle P and the angle R are congruent. So on these things, you can generally just kind of represent it on the triangle. It says QT bisects the angle PQR. So then you would say this angle then is this one, and you don't have to make the statement. You can just show the thing. And then this R is 61 degrees. It says find PQT. So here you'd probably want to make a statement that when that QT bisects PQR, look at one theorem
As isosceles?
and try to get something that would say that you could use to I guess that you could use to say that probably that thing is perpendicular. That'd be probably what you're looking for, is that at T, those are 90-degree angles. Is there a theorem would give you,
4.9.
okay. So you're saying if in an isosceles triangle, now is this isosceles?
Right, we can't determine that.
Yeah. What you'd have to do is, you'd have to go back and you'd have to say, well, what I'm gonna do is this theorem 4.7 says if two angles of a triangle are congruent, then the sides opposite these angles are congruent. Now then, that's isosceles. See, P and R are congruent. So you just say angle P congruent with angle R, and that's given. Then it's the sides PQ is congruent with RQ,
What would you call that?
and that would be theorem 5.7 or 7. Now you can say it's an isosceles triangle, or you could try proving it. You could go congruence, because you got these two angles equal, these two angles equal, and you could say there's congruent triangles, and therefore this angle is congruent to this angle. But you're trying to establish the size of the angle, so you probably want to go with the perpendicular bisector. That would be the theorem that you were using, 4.9. It says if an isosceles triangle, the ray bisects the vertex angle and is perpendicular to the base. So, and then you could say that these two angles are right, and QT is perpendicular to PR
No, it's zero.
by your theorem 4.7, right?
I think that was something like.
No, 4.9.
4.9, yeah, excuse me. Now then, you have 90-degree angles here, right, by definition. Then you can figure out what the size of these angles, and that's what they're asking you to do. Find PQT. So then you'd say P angle PQT. That's equals, and you'd go 180 degrees minus 61 plus 90. And to me, you kind of have to use a couple things to verify that that's true, but it's not a rigorous proof. What is that? 59. Is that 21 degrees? And technically, I don't know, I'm not going to be, but you would say the measure of angle PQT equals 21 degrees. And that's a non-rigorous proof, but you're kind of having to make some statements about what it is that gives you the right to do those different things. Any questions on that? Once again, I would not consider that a proof. That is simply a justification statement. See if I can get
But
this.
you will accept an improved form, correct?
Yeah, if you do a proof form, that's fine. But you don't, you can be a lot looser in step by step. Okay. I have to do this thing. Okay. This is A, B, C, D, and E. Now it says in the figure, triangle AD, ADE, and ABE are isosceles. Well, the only way that can be is, you know, this side right here and this side in ADB have to be identical. And then this side right here and this side have to be congruent. That makes your isosceles triangles. And we can say then that this angle and this angle is congruent, and this angle and this angle are congruent. I get to change colors. So it's, when we write it out, it's AD congruent to DE and AB is congruent to AE. And that these are given. And then I got, let's see, how do I want to do that? I'm not going to try to state the angles. I'm just going to, the congruent angles are shown. I'll just make that statement. Congruent angles are shown. So that I don't have to write, otherwise I have to go AEB and so on to verify the angles. And it's not that critical with me.
I am supposed to say angle.
What?
I am supposed to say angle A and angle E.
Well, the reason those angles are congruent is because if you go back and look at your theorem 4-5, it says angles opposite congruent sides are congruent. This is theorem 4-5. That's why those angles are congruent. And then ADE. ADE. So this angle right up here, ADE, this one is 50 degrees. And BAC. So this angle here, BAC is 45 degrees. And then want to find the measure of DEC and A, so I want the measure of angle BEC and the measure of angle ACE. So BEC and AEC. So, what do you think? If these two angles right here are congruent, those two green ones,
Mm-hmm.
and this is 50 degrees, so what you got, what you can say is that those two angles, and I'm just not gonna, I'm not gonna write it out, I'm going to figure it out. Then these two angles have to be half of 180 degrees minus 50. 130 degrees. Half of it, 65. So these have to be 65 degrees each. Now, you can do the same thing with the two angles here, this angle and this angle. You notice that your vertex angle, this angle right up here, this whole angle right here is the vertex angle, and that's 110 degrees, right? So if we take 180 minus 110, then we have 70, right? And half of that is 35. So that means this angle is 35 degrees, and this is 35 degrees. Now, okay. Now we can actually calculate ACE because we got 35 and we got a 65 in the triangle ACE. So if you consider the triangle ACE, then the angle ACE, the measure, is equal to 180 degrees minus the 65 degrees minus 35, right? So that's 80 degrees. And that's we've gotten this answer. Now the other one we wanted to get was DEC, and we have that as 35 degrees, right? This would be very hard to write up as a proof, and it'd be very hard for me to grade. As you know, I've done it here. if I did something like this, it would be something that I could see a lot clearer than what, is there any questions on that? Does it make sense? It's by no means a rigorous proof.
DEC is only 30, not 35.
Okay, this was 110. This angle right here, this purple angle right here is 110, isn't it?
Further to your right, sir. The angle at the very rightmost.
Yeah, well that angle's 110, so you take 180 minus 110, and that's 70, isn't it? So these two angles here have to be half 70, and that'd be 35.
Right, but now you're trying to find angle DEC, so 35.
Oh, D.
So you
Subtract
Oh,
from
DEC.
65.
Oh,
yeah, then,
I see.
Then add those
Yeah,
two, right?
I
That's
was-
what I was thinking.
I was thinking it was this one. We're trying to find this one. Yeah. You're trying to find, I don't know. We're trying to find this one.
Yes.
Okay, that was my mistake. So that thing, so it's 65 minus 35. This is 65 minus 35
Right.
is 30. Okay.
Right.
Okay, thanks.
You're welcome.
Okay, 6. Wow. I can pull that.
I have a question. Listen. So all this theory and stuff, I'm not sure we're gonna be able to know which theory. Can we have like a sheet of paper that can just deal with the theory?
What did you say?
You know, this we have to look at the textbook to talk about the theorems, to remember which theorem we are going to refer to. We're trying to prove this. We're trying to show.
Well, you should have that paper.
Theorem, is it in there?
Yeah, that all those theorems and corollaries, everything should be in there. So 6. So it's A,
No, they are.
C, B. I mean, that's why I gave it to you, because, I mean, I don't expect you to memorize them. But you're gonna have to know them well enough. So. Okay. Now, it might not, the way I drew it may not look like it.
Plus.
So they're showing us that this side and this side are congruent. This side and this side are congruent. In addition to the congruent segments indicated, it says AB is congruent to B is congruent to FB. So that's given. And this is going to be figuring out the size of the angles. And so if that's true, then I'm going to because AB and FB are congruent, we can say
Those sides.
that this and this is congruent, right? And then because these two are congruent, we can say that this thing is congruent to this one, correct?
Yeah. Let's try it.
And then maybe I should put a double in here. And then this one is congruent to that one. Okay.
Professor, how do you find the congruency on AFB? The angle AFB.
Because this AB and FB, AB side is congruent to
Okay,
FB
gotcha,
side.
gotcha, okay.
The side
And
is
that's given, therefore those, I could write it out, I guess I could write 2. The reason is the measure of angle, let's see, B, okay, you could go A, F, B is congruent to F, measure of angle, F, A,
Okay.
B. And that's that theorem.
Two congruent sides.
Yeah, that first one, theorems 4, 5. It says isosceles triangle, the angles opposite the congruent sides are congruent. This is theorem 4.5. Okay, and then ABF is 20 degrees. So this is 20. Find the measures of these angles. Okay. If ABF is 20, then that AFB and FBA, we can figure that out. The measure, I don't know how to do this, whether to do ABC. Maybe that's what we need to do. A is FAB. Okay, that's okay. The measure of angle FAB. And what that's going to be, it's going to be half of 180 minus 20, right? 180 minus 20 divided by 2, right? And that should be 80. So I'm going to write down here that this is 80 degrees. And then this is 80 degrees. Try to write it in green so that we know that that's the angle we're dealing with. And then this one is 80 degrees. So the B is saying angle FDE, the measure FDE, FDE. Okay. So this is what we can do. If if these two right here are 80, then this one right here has to be 20, right? Because it's 80 and 80 away from 180 is 20.
Means the opposite vertical angle will also be 20.
Yeah, this angle is 20 degrees, so that means these two have to be 80 degrees.
And how do you call those angles that is 20?
Well, these are equal because of vertical angles.
Yeah, what is it? There's a name for it. Oh, yeah.
Vertical angles are equal. So FDE has got to be 80. So C. Angle FCB. Angle FCB. So FCB. Okay, this one right here, FCB, has got to be 100 degrees, right? Because a straight angle minus 80, correct? FCB has to equal 100 degrees. And that's, okay. No, everyone understands that, don't you?
Are you supposed to subtract 80 from 180? Yeah.
A straight angle is 180 degrees, and you got the red 80 degrees, so it means that other one has to be 100. The measure of angle BFD. So BFD, well, that's going to be this angle back over here, right? And that's 100 degrees because it's a straight angle, and then you subtract 80 from it. See, this green one is 80, and the 80 plus that 100 degree makes that straight angle, straight line that goes through there. E, the measure of angle CFB. CFB. So that you're going to subtract 20 from 80, right? It's this one right here. And that's got to be 60. CFB. The measure of angle AFC. Okay, AFC. So that's that 20 degree. Okay. It's not a rigorous proof. It just kind of
Go through the
figures.
steps.
Yeah. turn out so good. Is it? Now you have to just give it to me. S T U V W and X. And then they're showing this is 90, that's 90. Then they're showing this side and this side are congruent. Oh boy. It says UX is perpendicular bisector of SW. So then what's given to you is that this is perpendicular and it's a bisector of SW. And then it's saying that this is 4 units long. Maybe I should put it that way. This is 4. And TU is 3. So we can say this is 3, right? The question underneath there is SU is congruent to WU by SU WU perpendicular bisector. SU and WU. If you, I think if you look at 211, page 211, theorem 410, and look at the bottom of that theorem, it says P is the perpendicular bisector of AB, and it's if P is a perpendicular bisector of AB, then AP equals BP, and that's what you have is that UX that makes that P a perpendicular bisector of line segment AB, then this side SU has to equal WU.
So
That's theorem 410. And then the next one, B. So let's see, how should I do this? This one and this one are congruent. And then this angle and this angle are congruent. So triangle STU is congruent to STU. So that would be congruent to
WVU,
WVU.
side angle side.
Okay. Let's see. And then VW equals, and they want to know the measure of that.
Equal to T is now the latex angle, right?
What's that?
Latex, something about to do with latex angle. That's like the previous one.
Hmm. See.
Alright, if you remember, last one just did.
How you gonna go about this?
That should be
I had it
latex
figured
angle.
out one time. Hmm. Oh, is that?
This.
Well, I'll figure it out and come back, cause we've got a little over time, or if you can figure it out.